Let's look at some examples of our homework problems from 7.1. So number 23, this question is about a wedding. It says a florist has 20 dandelions and 30 thistles to make a relatively inexpensive wedding bouquet. Please don't actually buy wedding bouquets that are made of these weeds, but in this case, we went cheap. So A, the first part of the question, what is the greatest number of identical bouquets she can make without having any weeds left over? And B, how many of each kind of weed will be in each bouquet? Looking over our possible weeds, we have 20 dandelions we can use, and we have 30 thistles that we can use. So if we want to find the greatest number of things that we can make, we need to find the greatest common factor of these two. So 20 we can break up into 2, which is prime, times 10. 10 is not prime, we can break it up into 2, which is prime, and 5. So 20 is 2 times 2 times 5. I'm going to write that over here. 2 times 2 times 5. All right. Moving that aside, shrink that down, move it over here. Let's look at 30 then. 30, similarly, is 3 times 10. 3 is already prime. 10 is 2 times 5. Those are both prime. So 30 is the same as 3 times 2 times 5. Okay. Looking at our prime factorization then, we're again factorizing out our two numbers. The only things that happen twice, we have a 2 and a 2. We have a 5 and a 5. So those we can factor out, and we'd say then the greatest common factor is 10. So A, what is the greatest number of identical bouquets she can make without having any weeds left over? That would be 10. That's our answer to A. Circle that. How many of each kind of weed will be in each bouquet? Well, if we made 10 bouquets out of 20 dandelions, there would be 2 dandelions. You know what, I'm just going to use the text box. 2 dandelions. Oops, I got a D there. Dandelions. And 3. If we took 10 bouquets with 30 thistles, it'd be 3 thistles in each. So that would be our answer then. 10 bouquets. Each bouquet has 2 dandelions and 3 thistles. So we found the greatest common factor of our two numbers. Let's look at our next example. This one has to do with Sesame Street. Cookie Monster wants to package the same number of cookies in each bag, and each bag contains every type of cookie. Okay, well, Cookie Monster has 54 M&M cookies. He has 40 chocolate chip cookies and 30 peanut butter cookies. If he puts the greatest possible number of each cookies, or of cookies in each bag, how many bags can he make? Well, obviously, he could make one bag and just have 54 of the M&M ones, 40 of the chocolate chip ones, and 30 of the peanut butter ones. He could easily just make one bag and put all of them in there. But could he make any more than that? Could he make multiple different bags that have the same number of cookies in each one? Well, to find this out, we'd, again, like before, have to factor this. So let's start with 54. We can break down into 6 times 9. Neither of these are prime because 6 we can break into 2 and 3. Those are both prime now. 9 we can break into 3 and 3. So those are prime. So 54 would be 2 times 3 times 3 times 3. Okay, let's look at 40 then. 40 we can break into 4 times 10. Neither of those are prime because 4 we can break into 2 times 2. Those are both prime. 10 we can break into 2 times 5. Those are both prime. So that's the smallest way to break down 40. 2 times 2 times 2 times 5. Run out of space a little bit here. I'm going to shrink this down. Shrink this down. Oops. Give us a little space to work. And the last one, 30. 30 can be broken down into 3 times 10. 3 is already prime, so that'll help us. 10 is 2 times 5. Those are both prime, so we can say 30. We break it down into 2 times 3 times 5. So these are our factored down into their prime factors. These are the factored forms of 54, 54, 40, and 30. So now that we have our factors, we'll look at them and say, what are the only pieces that repeat? Well, we have 1, 2 in each of these. We have a 3 up here, but not here. Another 3 here. We have 5s here and here, but not in this top one. So 2 is the only thing that we could pull out. So we would say then that there are 2 bags at most that he can make. Now, at this point, that's technically the end of the question. If we wanted to figure out or say how many of each kind there were, well, for the M&M ones, there's 3 times 3 times 3, so we'd say that's 27 M&M cookies. For the chocolate chip ones, there's 2 times 2 times 5, so there'd be 20 chocolate chip cookies. And for the peanut butter ones, there's 3 times 5, so 15 peanut butter. I'm just going to do PB. But yes, in the end, we would find out that there could only be at most 2 bags made so that all of them have the same amount of cookies in them. Perfect. So that'll end our examples.